Measures of spread. Two measures of spread are standard deviation and variance. The variance is the square of the standard deviation. So you'll see that there are formulas here. If we pair them up, look exactly the same. When you're looking at population, notice that your denominator is n. When you're looking at a sample, notice that you subtract 1 from n because a sample underestimates the deviation. So deviation is the difference between an individual value and the average for the set of data you're looking at. An example. Use means and standard deviations to compare the distribution of heights for the two basketball teams listed below. We're going to treat each team separately and as a population, not a sample, because you're going to use every team member. And now the solution. So the sum of all of these heights is 1155. There are 7 players. That means the average is 165. So 1155 divided by 7. The deviation of how far away from the average the height is gives you the deviation value. So 183 minus 165 is 18. Jamie happens to be right on the average, and Deepa is 17 below that average. To create the standard deviation, you square that difference, and we are going to add it all up, so it becomes 1520. So the calculation is the square root of 1520 over the number of players, which is 7, and so that is 14.7. So that is the Falcons. If we're to do the same thing for the Ravens, the standard deviation would equal 2.1. So what this means is that the Ravens have a much more tightly grouped set of players around the same height, and the Falcons, their difference in heights is wider. Another measure of spread is quartiles. And what quartiles do is divides a set of data into 4 equal groups. The 3 dividing points are the first quartile, the median or the second quartile, and the third quartile. So this will split the group into 4. What we're looking at here is called a box and whisker plot, and that box and whisker plot takes the lowest piece of data and takes you all the way to the highest, and then divides it into 4. So you can easily see the group of data into 4 pieces. What we have here is an example with outliers, and when you have outliers, you then leave them indicated above or below the rest of the data, and then adjust the upper whisker or the lower whisker depending on the data that you have. There is a convention that we like to use, and outliers are indicated if any point is at least 1.5 times the box length from the box. So if the box length or the interquartile range is here, then 1.5 is your measuring stick, and because these 2 pieces of data are beyond that, we're going to call them outliers. The same could be said if you had some data points on the lower end. You would also call those outliers and use the same measuring stick. Creating a box and whisker plot. We have a random survey of people at a science fiction convention, and they are asked how many times they have seen Star Wars. The survey results are here. The first thing you're going to have to do is put them in order. And once you put them in order, you're going to find the median, which is quartile 2. And this median certainly is the middle of the data, but then appreciate between the lowest point and the median is another median. And we call that quartile 1. And this up here is quartile 3, but that's also the middle between the median and the end. So really what we're doing is finding 3 medians and graphing it in a box and whisker style. First things first, we put our data in order, and then we find the median. So we count up our data points, and we know that the median is in the middle. So the median is going to be 5 plus 6 divided by 2, which is 5.5. So in our box and whisker at about 5.5, I'm going to indicate right about there. Now we're going to find the other 2 medians. So the one on the lower end is between the 2 3s. So we're going to add those together, divide by 2, and that gives us 3 yet again. And 3 is about there. On the other end, quartile 3 is right at 10 exactly. And so I've plotted it. Now, the lowest possible value is 1, and the highest value is 30. So I'm going to draw my box, and my whiskers. Now hopefully you can tell that this data point up here is more than 1.5 box lengths, which means it is an outlier. So I'm going to retract my whisker on the upper end. So I'm just going to get rid of that. I'm going to retract it back down to my next largest point, which would be 16, which is right about there. So there's my 30, there's my 16, and here's my upper whisker. So lower whisker, upper whisker. So most of your data is in the interquartile range. And your interquartile range is 10 minus 3. So your interquartile range has a value of 7. So the question is, how does this compare to last year's results of a median of 5.1 with an interquartile range of 8.0? So last year, the range was just a little bit more. Percentiles divide the data into 100 intervals that have equal numbers of data, just as with quartiles that split the data into 4 pieces with equal pieces of data. A couple of good examples for percentiles that you may have heard of are standardized tests and baby measurements. So an example, an audio magazine tested 60 different models of speakers and gave each one an overall rating based on sound quality, reliability, efficiency, and appearance. And we have 3 questions we can now answer. If the Audio Maximizer Ultra 3000 scored at the 50th percentile, what was its raw score? So we have 60 pieces of data. Draw a line down the middle. That gives us 30 on each side. So 50% would be these 2 pieces of data added up together and divided by 2. So for the Audio Maxer, simply add them together, and you know that it's 67. So the raw score at the 50th percentile is 67. What is the 90th percentile for these data? So again, you pick out your numbers. So the 90th would be between 88 and 90. So we have 60 pieces of data. We want the 90th percentile. So we're looking at item or piece of data number 54 and 55, and we're going to take those, add them together, and divide by 2. So this will be 88 plus 90 divided by 2, which is 89. So the 90th percentile would be a score of 89. Lastly, the Schmedervox score of 75, does that score place it at the 75th percentile? Well, we can see a whole bunch of 75s there, but does that score actually hit the 3/4 mark? So again, 60 pieces of data times 0.75, and that's going to equal data point number 45. And that puts us here at 79. So we add the two together, and hopefully you can see that that result would be 80. So the answer to that question is no. A score of 75 does not place it at the 75th percentile. It's well below that value. Last item, Z-scores, or Z-scores if you're American. So a Z-score is the number of standard deviations that a piece of data is from the mean. So let's say the average, so you have a spread here of data, and the average is here. You have a piece of data slightly above the average, and a deviation that is this long. And what a Z-score does is measures that fraction. Okay? So a Z-score is the deviation divided by the standard deviation. And again, there's a couple different formulas, one for population and one for sample. So we're going to determine the Z-scores for the Audio Maximizer Ultra 3000 and the Schmedervox speakers. The average is 68.1 and the standard deviation is 15.2. So we're going to plug in our values. So 67 minus 68.1 divided by 15.2, and that will be negative 0.72. And for the Schmedervox, the Z-score will turn out to be 75 minus 68.1 over 15.2, and that is 4.6. So the Schmedervox is below, and sorry, the Maximizer is below, and the Schmedervox is above. Thanks for listening.